Hi, we go back to the electrochemistry. The cathode, catharine, GER, and gets electrons, gets mass, gets cations through the ion bridge. So that's what you have to remember. Just like catharine, just like Irene, right? Only one side you have to memorize. The other side is the opposite. Look at this reaction. Zinc goes to zinc 2 plus. It's a Leo. Losing 2 electrons becomes zinc 2 plus. If it is oxidation, it's called the reductive or reducing agent. That's a secret agent because it's doing oxidation, and it's called the reductive or reducing agent. So that's how you remember secret agent. Now, if this is secret agent Ra, the other one is oxidizing agent. It should be opposite, right? Then it should be doing reduction because it's oxidizing agent. So that's what's happening. So copper 2 plus becomes copper 0, which is reduction. And the copper 2 plus, the reactant should be called oxidizing agent, right? So only the reactants we focus on oxidizing agent and the reducing agents. Okay. Now these reactions, just a simple steps to understand where to put the electrons. You see 2F minus in your left, and you need to add 2 electrons into the right to balance the charges, right? And the aluminum 3 plus, you need to add 3 electrons into the right. I2, left 2 electrons. SN2 plus and SN4 plus, 2 electrons to the right, right? And then SN4 in this side now, left side, then 2 electrons to the left, right? And likewise, so you can you stop the video and you can practice that. So learn to add electrons into each side, right? Now we can label them. If it is to the left electrons, left for Leo again, right? And if it is to the right side the electrons, it's GER, or GER for the right, right? R for right. Okay, so that's how you kind of remember that thing. And then you can practice, stop the video, practice all of them. Simple steps, one step, GER or Leo. Now, we are stepping into more complex one. This one has both half cells. So the GER and the Leo, right? So in this case, what do we do? So let's sort it out. Let's break down two separate reactions. Copper 2 plus become copper. That's the GER. That if it is GER, that should be oxidizing agent, the secret agent. Now, so let's write them by the side, and then the other one, zinc, goes to zinc 2 plus. It's a Leo, then it should be reducing agent, right? Because secret agent. Okay. Now, zinc 0 goes to zinc 2 plus and kicks out 2 electrons, balancing the charges, you see. Each side becomes 0 charges, right? Because charges cannot be created or destroyed. That's why. So copper 2 plus gets 2 electrons, becomes copper. That's the reduction. So you have the 2 steps. That's also happening. In the top one is anode, bottom one is cathode, right? But you can do the same thing for the here. So H plus gets electrons, becomes H2. That's the oxidizing agent. And 6H plus should have how many electrons? 6 electrons, because it makes 3 hydrogen by adding 6 electrons, cancel the 6H plus. And that way you get the 3H2 gas, right? So you can do the same thing for the aluminum. So the aluminum is a Leo because aluminum goes to aluminum 3 plus, but you have 2 aluminum. So it should make 2 aluminum 3 plus, which is 6. 2 times 3 is 6. You need 6 electrons to balance. So just be aware of how many electrons and which side, right? And you can, so barium also the same thing. Barium goes to barium 2 plus, and the 2 electrons are kicked out, and then the 2H plus gets that 2 electrons and become H2. So it's always redox is balanced. There's no electrons floating around in the air. So electrons only go through the wire, right? Conductor, and that's how it is, right? So this is another one. So you can stop the video and try to balance the electrons to each side. Look at the charges and balance it, right? Practice that. And we go on to the next one, which is complete balancing equations. Okay. All right. Let's move to the next one. Here, yes, the what is released electrons will be used in the other one, right? Okay. So, yes. So we're going to write a few steps for the balancing equations. So they separate the Leo and Ger, balance their other elements without the H and O, then balance oxygen with water, balance H with H plus, balance charges with electrons, finally check the oxygens. Those are the few steps. Put it in a piece of paper and keep it on your desk so you can do every time. So look at this one. Copper 0 goes to copper 2 plus. And so you see there's no other balancing to do. So we're going to check. Only step is to do is the electron balance, the charge balance by adding electrons. So 2 electrons to the right. It's an easy one. So let's look at this one. NO3 minus goes to NO. Now we have to balance oxygens first. So 3 in the left, 1 in the right, add 2 water. Now the proton balance, H plus balance, add protons, 4 in the right and need 4 into the left, right? Now check the charges. Your right has 0 charges, your left has 4 plus and 1 minus, that's a 3 plus. You need 3 electrons to the left. So 3 electrons to the left, 4H plus, NO3 minus, NO2 water. So that just copied everything one more line, right? Now you can balance the electrons with the common least factor, which is 3. And for the bottom one, it's 2. So now multiply with the outside the bracket number and put together. So first one, 3 copper goes to 3 copper 2 plus, right? And next one, 4 times of 2 8 hydrogens and 2 NO3 minus and 3 copper 2 NO and 4 water. 2 times 2 water is 4 water. So now that's it. Now we just see anything to cancel? No. And check the oxygens left and right. Look at your right side, 2O and 4O. So that's 6 oxygens on your right. 2 times 3, 6 oxygens. If the oxygen balance, everything is balanced. That's a magic check, right? Check the oxygens. Don't check anything else, right? Okay, look at this one. Fe2 plus goes to Fe3 plus, then electron should be here on the right. That's a Leo, right? And then look at the chromine. Cr2O72 minus goes to Cr3 plus. Just know dichromate is orange color. Cr3 plus is green color. You need to know the colors actually. Okay, so Ger reaction Cr2 plus, we need to balance the Cr2 with the 2 here because that's the balancing of other elements, and then 7 oxygen, 7 water, and 7 times 2, 14 H plus. Now the balance the charges, right? So that would be 6 electrons, right? So for the left side. Now you balance the electrons. The top one should be 6 times, then 6 times of Fe2 plus and 6 times of Fe3 plus, and then add everything else. Check the oxygens finally. Your right has 7 water, 7 oxygens. Your left has 7 oxygens. Voila, everything is good. So slow down the video or stop the video and do it by yourself every step. So then you will be fine. So what I'm practicing is the most common ones, right? So this is another one. So again, dichromate, the orange one, and it becomes Cr3 plus. Balance the chromium first. 2 chromium in the left, 2 chromium in the right. Then 7 water for the 7 oxygens and 7 times 2, 14 H plus for the left. Now you check the electrons and 6 electrons for the left, right? I2, you need to have 2 IO3 minus because I should be balanced, right? And then add water, 6 water to the left and 12 H plus to the right. And then balance the charges, you need 10 electrons, right? Okay, now 10 electrons in the green and you need 10 electrons on the red. So that's the common electron exchange, right? Now you put together left to the left, right to the right. So you got these numbers. This is a big one. If you are not really comfortable, you don't have to do this question. You can do other ones. There are easy ones, important ones, right? So check it out. You can see whether everything, you can cancel out extra ones. And so check it out slowly and see whether the numbers are correct, right? Okay, let's look at the next one actually. So the numbers are right. I checked the oxygens and it seems it's balanced, right? And if this oxygen is not balancing each side, then you should go up and check any mistakes you did in the multiplications and anything like that, right? So, but this is a really good test to do, check the oxygens of left and right. Finally, if it is balanced, that means you have done everything right. Okay. So this is an important one because it is methanol. We're going to do the ethanol as well. So the permanganate, know this one, this is purple color. That's another one to know. So the permanganate goes into Mn2 plus. And so then we need 4 oxygens. You add 4 water. Then 4 water has 4 times 2, 8 H plus. Now you check the charges. Your right has 2 plus. Your left has, to balance, you need 5 electrons, right? The other one, methanol, goes into formic acid, HCO2H. I call the HCO. And you add 1 water to the left, and you need to add 4 H plus to the right to balance the H plus. Now, the charge balance has to be 4 electrons to the right. Now, common denominator, 4 and 5. And multiply the top one by 4, multiply the green one by 5, left to the left, right to the right. Put them together. So you can stop and slow down the video and then do that and see what you get. Now, there's a little bit of something here. See, water to each side should cancel out. And H pluses from each side should cancel out by the number. By doing that, we get the net equation and then check the oxygens. You should be fine. Now, so I'm okay. Homework, boys. So that one is homework. I'm going to leave that one. But I thought this is an important one, the ethanol, because this is what happening in the breathalyzer test. So it's actually orange dichromate will become green Cr3 plus, and this Cr3 plus green, this will be checked either in a electrochemical cell, like I said. It will be checking how much of acetic acid the vinegar is formed, depending on how much ethanol in the blood alcohol coming through the lungs to the breathalyzer, right? Or there's another one called the IR test. Those two are in those little packages, the little apparatus that the cops carry, and they will get a digitized number, and then that's how we get tickets, right? Okay, so ethanol becomes acetic acid. So for balancing, I'm going to add water into the left, and then you need to add 4 H pluses to the right to balance the H pluses of whole left to the whole right, right? So check the total though, not one species now, right? Now, so we can rewrite the Cr2O7 goes to Cr3 plus. We need 2 again, because there's Cr2, then 2 Cr3 plus, right? Now, oxygen 7, that would be 7 water, 7 times 2, 14 H plus to the left, and then check the balance of the charges. You need to have 6 plus here, that means 12 plus here, so that means 6 electrons, right? Okay, so now that's done. Now so we have 4 electrons on the green, and we have 6 electrons on the red, so we need to balance 3 times 4 and 6 times 2, that will be 12. That's how we balance the electrons, right? Now, it will give me the left to the left, right to the right. So 3 ethanol, 3 water from the green one, and then 2 chromate and 28 H plus from the red. And then your right side, you have 3 acetic and 12 H plus, and then 2 times 2, 4 chromium, Cr3 plus, and 14 water. Now we can see what to cancel out. 3 water should cancel out with the 14 water. So that will left with 11 water. Now 12 H plus will cancel out with 28 H plus. You will left with 16 H plus. So that's the net. Now let's check the oxygen. Your left has 3 here and 14 there. 3 on the ethanol, 14 on the chromate. So that will give me 17 oxygens on the left. On the right, you have 14 water. That means sorry, 11 water and 6